All right. Hi, everyone. Um, I guess we can get started now. So, welcome to tonight's workshop, Deploy a Multi-Language Application using through Docker. So, basically tonight we're going to teach you guys how to stick to what empower yourself through Docker. We're going to kind of show you guys how to build these kind of complicated web apps that can use multiple languages. So, if you're using Ruby and your friend is using Java, you guys don't have to fight over who uses what. Stick to what you know. Before we get into it, we should introduce ourselves. Hi, I'm Eric. I'm a second year CS student at the University of Waterloo. Down below are my socials. You guys can take a minute to connect if you want.
And I'm Annie, and I'm a data scientist in the NLP research and development team. So here's my GitHub and LinkedIn if you want to get connected. And I'll be co-leading this workshop along with Eric today. Hope you all are excited.
All right, great. So we're going to kind of go over today's agenda a bit. By the way, if you guys haven't already, we suggest you guys to look at the hack pack, and you guys can ask questions into the Slido. And just, I guess, overall get prepared for today's workshop. So the agenda for today, as you guys can see, we're going to start with kind of explaining a bit about the web. So I know some of you guys probably already know what HTTP and what REST APIs are, but we're going to take a good analogy to kind of get you guys understanding why we want to use Docker in terms of explaining, different ways of building web servers, which are monolithic and microservice architectures. Then we're going to have Annie lead that kind of section of explaining what Docker is and to start coding it. And we're going to give you guys a little break because we know it's quite long and you guys might be tired of workshops already. So we're going to take a quick 5-minute break in the middle. And we're going to, at the end, deploy a multi-language application to the cloud. And we're going to make a goose counter app kind of stuff. So I guess we should start with, what are web servers? It's time for analogies. It's time to understand what is HTTP and what are microservices. So I'm supposing you guys have some knowledge of the internet. I'm supposing you guys, know that there is this thing called the internet, which is just basically a network of different computers. And, the way I like to think of it is that some computers are houses and other ones are factories. Some computers, for example, Google, is just this big factory that kind of serves you, maybe food. It may, make bicycles for you. It can make whatever it wants for you, right? And then at your house, you go to these big factories and you kind of order the stuff. So you can think of like these big factories as Costco or something like that. And your house or each other computer that isn't giving stuff away, it's kind of taking stuff away. And you can think of that as your own house. So why is this kind of important to know? This is important to know because we need to have this common road between, these factories and our own houses. We need to be able to kind of travel between these. And if you think of the internet, it's kind of mysterious in the kind of magic box of how we kind of are able to get information from these big factories, right? And so the way I kind of like to think of it is that there's this kind of common highway in between your house and the different factories we have, or as we call it, HTTP as the actual lingo. So if you guys kind of go to each website, you can see HTTP or HTTPS. All that means is the kind of way that we're transporting between your house and the different factories. And not only are there this kind of common road between these, but there's also kind of different delivery services that can be from your house to the different factories. So for example, if you think of Costco, let's say a lot of people end up going to Costco and spending a lot of time trying to figure out what they need to get and stuff like that. It doesn't make sense for these big factories to kind of just keep it that way. It might make sense for them to kind of build this kind of, interface or this service between your house and the big kind of factory so that you can actually drive on the road and you're not just walking on the road, if that makes sense. And so that kind of idea behind having this common service in between your house and the different factories is known as an API, or just kind of application programming interface. Long story short, it's just this like mailing service that you can get, orders from to a factory, or in terms of the actual computer, you can actually get different resources or different websites and stuff like that. And what's important to note here is that the mailing services need to know where you want to go, which factory you want to go to, as well as what to do at each factory. Do we kind of get more information, or do we kind of create more information? And that kind of stuff is important in building these kind of factories, as we'll discover later on. And so the reason why this is important is because think of Google, right? Google isn't just this one big factory. Imagine you had like this one big factory in the middle of the US and everyone had to walk over there or get food delivered from there. It doesn't make sense because, people are going to spend way too much time on the highway. So the way that these kind of big services or these big companies kind of create these, available ready factories for everywhere across the world is that they replicate them. And so one of the ways to replicate them is just to take whatever store you have. So let's say, for example, you're building a factory that serves Python, Java, and Rackets. As you can, for those of you guys out there who recognize that those are all programming languages, kudos to you. Anyways, my point was that we have these kind of stores all bundled up into different factories. And these factories are just replicated across the world, which works great towards a certain point. The problem with this is that, let's say we're in Canada and we're heavy coffee drinkers, but, we don't really want to see snakes around all the time. Let's say we need a lot more coffee factories, so we replicate like 4, 5, 10 of them, right? The problem is that, as you can see, this factory also includes a snake. So what we're doing is we're also replicating the snake 10 times. And that kind of wastes a lot of resources that we don't really need. So what can we do instead? How can we make sure that we can replicate the coffee, but not the snakes when we need it? The way we can replicate this is through this kind of other terminology that we call a microservice architecture. The basic idea is that each store itself is a factory that you can replicate. So for example, if you're in the US, we already had Tiger King. Let's say someone wants to become a Snake King and have a bunch of factories out of snakes. What you would do then is just kind of replicate the snake factory over and over again. So in terms of how this actually works in code, the monolithic architecture, you can imagine as a huge code base that you just kind of replicate from computer to computer and just run it all at once. Whereas in microservice architecture, you have multiple smaller code bases and you run each of them in different places at once. I hope that kind of makes sense. And so what's great about the microservice architecture is that, let's say you're in Canada, you want a lot of coffee, you can just replicate the coffee. But we come across another issue here. So I'm not sure if you guys can tell, but sometimes these microservices, these stories need to be able to talk within each other. For example, let's say someone works at the racket shop and they need some coffee in order to get started. Well, how do these different factories communicate with each other? Because before, remember, this is one code base. They can just call each other's code and stuff like that. But here, these are two completely separate code bases. They're not able to talk to each other just through code. So what can we do? How can you create this common road or a common highway in between these? The way that we can create a common highway is just reutilize the highway we had before, but between our services this time. So what we can do is create our own little kind of tiny city or our tiny network of HTTP highways in between the services to kind of get the information that's necessary. But this also raises another issue. How do we actually start up all these factories? Because before with a code base, you can just run your application and it's perfect, right? It runs really well. But the problem is that when we have microservices, you might have to run different applications at kind of different places in the code, and you have to kind of manage all of that. And you have to, every time you want to make one little change, you might have to restart the entire thing, and it kind of gets really messy, right? You might forget how to do it, and everyone has to onboard onto all the 3 different factories and know how to set it up. And because of that, it might get a bit messy. So how can we kind of, make this better? How can we have one thing kind of run everything at once? Well, that's what today's workshop is about and what Annie's going to talk to you about, which is how Docker can help. So we're going to wait for Annie to come over.
Yeah, thanks, Eric. So thank you for introducing the great topic that we are actually going to discuss today. So as you've already been introduced, you've actually been introduced to what's microservices and what's monolithic services. And Eric finally asked you the question, how do we actually do that? So one popular way of actually achieving what Eric just described is by using Docker. Now let's actually see what this Docker is actually all about. So before actually getting into Docker, let's actually see some kind of numbers. So let's actually see that if we look at these numbers, you might actually be getting hyped up right now, even without knowing what Docker is. So basically, sorry. Yeah. So basically, I guess Docker is a containerization platform that's actually being used on 7 million applications and 13 billion image downloads. So we're actually going to learn what these individual things are as we move forward. So before actually getting into Docker itself and learning about how to actually use Docker, we need to actually learn about what are virtual machines and what are containers, because that's crucial to understand before actually getting into Docker itself. So you must have already faced some kind of a situation where as a developer, if you are actually working on, let's say you're actually working on some app and you're working on a Windows operating system. You've actually built the entire application, you're actually satisfied with the results, and you're very happy that all the builds are running and you're actually deployed your app. Now someone is working on a Mac and you're actually collaborating with them, and you hand over your app to actually make it start working on their system, and it starts crashing. You don't know why. It's actually working so good on your system. Why isn't it working on someone who has a different operating system? That's the whole problem that containers and virtual machines are actually trying to solve. So let's start with a virtual machine. I won't get into too many technical details. I'll just keep it on a very high level. So a virtual machine is nothing but a piece of software that emulates your entire operating system along with all the files and everything necessary. It's just as if you have a Windows machine or you have a Mac OS system and you're actually running an entirely different operating system on your own laptop or your own PC. That's essentially what a virtual machine is. So it's basically a software package that's emulating your entire operating system in one place. So let's actually why do you actually need virtual machines? The reason is you might have developed an app that's actually meant to be working on Linux machines, or that's meant to be working on Mac OS. That's when you actually need a virtual machine to actually make sure your app is in I would say a protected environment. By that I mean it's in an environment where it has all its dependencies and everything installed, and then the person who's actually using your app just needs to get in, doesn't need to worry about any of the dependencies. They only need to install something like a virtual box and then just start running the app. But let's look at what are some of the drawbacks. So let's say you have your app and you've actually made number of different instances of the same app to serve hundreds or thousands of users. In case of a virtual machine architecture, you would have to create an individual instance of the virtual machine. You would have to actually create multiple instances of the entire OS each time you want to deploy different applications. Like you would have to actually install the whole OS, which would actually be in gigabytes, which is actually a huge overhead. And this is not so memory effective. So containers actually solve this problem. So what containers actually do is, containers, the way containers work is they're actually a lightweight operating system. So let's say you're actually deploying multiple apps. If you look at the picture on the right, you don't need to keep installing multiple operating systems each time you want to actually deploy a new app. All you need is a container engine. That's what we'll be talking about today. The container engine actually makes sure that all the required dependencies that your app has are in an isolated environment, and it makes sure that the app starts working in such a way that it doesn't need the entire OS to actually run the app. It shares some resources from the host OS. By host OS, I mean the machine that you're running your container engine on, and then it installs only those minimal required dependencies that the app actually needs to run. In that way, the essential difference is, in case of the picture on the left, you're actually installing different operating systems each time you want to get an app. But on the right side, you only have one operating system, and then if, let's say, app 1 needs Linux to actually run it, it installs only those minimal dependencies that needs to be installed just for app 1 to make it run. The rest of it, it doesn't. It actually shares it from the host operating system. We'll actually get to know more about it once we actually see what it's all about. Now, I've actually talked about container engines. Docker is actually one such platform. Docker is a containerization platform that actually allows you to do this. So basically, Docker is not the only one. You have alternatives like Apache Mesos and many other containerization platforms that allow you to do the same. But Docker is a very popular, one such popular platform that's actually picking up a lot of traction in the past few years. So basically, just as I said, Docker is the one that's actually going to allow you to allow you to deploy multiple apps, allow you to basically isolate different apps and make sure that each app runs with its own dependencies installed without bothering about what's happening in the other app. So that's what Docker allows you to do. So if you understood, so container can be taken from the generic English word container. It's just a single container, like a box that has all the dependencies installed. And then Docker actually allows you to create those containers. It actually allows you to create all those dependencies on which the app will actually run. So you've probably seen this whale picture quite a lot of times. So now you actually know what this whale carrying the containers on its head actually means. So how does Docker actually work? So it's divided into three things. There's a client, there's a Docker host, and then there's a registry. So let's break it down into three different parts. So a Docker client is nothing but your the commands that you enter into the command line terminal. Whether you have Windows, it's a command prompt, or it's a Linux machine, it's a terminal. The client basically takes in all your commands, whatever you've entered. Just like, let's say, if you're used to Git, you're used to typing git add, git clone, or if you're a Python programmer or a Java programmer, what are your command line tools? You just type javac and then you try to run some Java file, or you type Python and you run some Python file. In the same way, the command line is used to execute Python containers. Sorry, the Docker commands. That's what the client is meant for. Now, once you run these Docker commands, the Docker daemon is something that actually takes these commands and does what it's supposed to do. So let's say you want to build certain Docker images. We will talk about images in the next slide. So let's say you want to build Docker images. You just say Docker build, and what the Docker daemon is going to do is it's going to take this command, Docker build, and then it's going to run it and then actually build the image. Now, the third piece is the Docker registry. So if you're familiar with Git, which I'm sure many developers are already familiar with, GitHub is a repository to store all your code. In the same way, Docker registry is nothing but it's a repository to store all Docker images. So now that I hope that these three different things are actually clear, because these three are what actually make up Docker as a containerization platform. So you only have three things: Docker client, Docker daemon, and Docker registry. Now we'll actually get into what Docker images are and Docker containers are before actually going into the first live coding session. So let's actually break this down into simpler terms. Let's start with a Docker image. So think of yourself as a car manufacturer. Before you actually design a car, you actually need kind of a blueprint. You need you don't directly go and fetch the parts. You actually need some kind of a blueprint. You need some kind of an instruction sheet on what you need to do. You need the specifications, the size of the body, the size of the engine. You need all these different specifications to actually start building the car first. So those specifications are equivalent to layers. So they are the different layers in your Docker images. So a Docker image is nothing but a Docker image holds all the instructions, or it's basically a software package that contains all the instructions needed to run your app. So let's say you have a simple Python web application. The Docker image would hold all the information related to all the dependencies. So the image would have all the information about the saying that, okay, this app depends on Python. This app depends on certain packages in Python. I need certain files within to run my app. All that information is clubbed together into something called an image. This is your blueprint, or this is basically your design. Now, let's say you actually manufactured the car. Your car is ready. From your image, you actually constructed your car. The car is sitting still. When you actually start your car, that's equivalent to saying you turned your image into a container. So a container is nothing but a running instance of an image. So your car is sitting idle. That's your image. You have everything built out. All the package and everything is ready, set to go. You just need to start your car. Starting your car is actually equivalent to running your container. So now that you're running your container, your app is actually running. That's what Docker images and layers and container actually mean. When you actually write code and when you actually build a Docker image, you will actually see that each layer is being built step by step. So what's going to happen is, what I've actually shown on screen is basically the Docker image being built layer by layer. So the first layer would be what's called a base image or a scratch image or a parent image. So the first image would basically be the first layer would basically be the image that you build, on top of which you build other images. So a layer is nothing but a stack of images. So an image is nothing but, remember that an image is nothing but a software. It's just a piece of software. And the first image could be install Python. That's the first image. The second image could be maybe install install pip to actually install Python packages. Or if it's let's say if it's JavaScript, if it's a Node application, install Node. So those are the different images that you actually build step by step. And then once you actually build the image, what Docker is going to do is it's going to create something called a writable layer at the end. And then finally, that writable layer is basically allows you to modify certain files on the fly. So enough about these explanations. Let's actually see how do I actually build the image. So the first thing that you need to do to actually build your Docker image is you need something called a Docker file. So remember when I said you needed a blueprint to actually construct your car? This Docker file is essentially that exact sheet. These are actually individual instructions that you give to Docker, saying that I need to install Node. I need to create a working directory for my app. I need to copy all my required dependencies, and I need to install npm. So basically, these are the lines that you actually enter into the command line. But in this case, Docker is actually doing that for you. So Docker is actually creating an image that is made up of each layer. So each layer is actually one line. So that's what this Docker file is meant for. Docker file is like a blueprint for you to actually run the layers step by step and then build your entire image by placing those layers like a cake. So that's how you can treat the image. It's just like a cake. So we will actually see this in action. I hope that you clone the repository called Docker Basics. Once we actually go through the live coding session, you will realize what's actually happening behind the scenes. So these are the most common Docker commands that you will be using. So these are the commands that we will actually keep seeing again and again, and you'll actually be using these commands very frequently. So the first thing is Docker build. It basically builds the image. Now that you specified all the instructions in Docker file, you are actually telling Docker, hey, take my instruction file and run it as I've actually explained it to you. This is what you're saying to Docker. And then you're saying, obviously, each car has a name, right? There's a Ford Mustang, there's a Honda Civic, there's a Toyota Corolla. You need to name them. So obviously, that's the name that you're actually giving. You're naming each image. And then once your car is ready, you want to actually start it and move it. So that's like saying Docker run. You have your image, then you're running the image, and then it's turning into a container. So that's the small niche difference between these two. And then these are the other commands that we'll actually see in the live coding session. So enough of all this theory. Let's actually start coding something so that you'll actually get a real feel of how Docker actually looks like and how you actually can build Docker images from scratch before moving on to actually deploying your app, which is the Goose Counter. So let me share the other screen. Okay. I hope you can see this. Okay, so I hope you have all cloned the Docker. I hope you have all cloned the Docker basics repo. So basically, you should basically have the repo downloaded and ready to go if you actually want to code along with me. So basically, make sure that you have all these files. Make sure you actually have a Docker file, and then make sure you have this app.py. It's a simple Python Flask app. No need to worry. You don't need to actually know anything about Python, and that's the beauty of Docker. So you actually don't need to know anything about Python or any dependencies. You just need to know how to create Docker files and how to actually run them. Once you actually do that, then you only need to know certain things about Python, like package dependencies, for the person who's actually using Docker in their team. So before you begin, I hope that Docker is actually installed. So make sure that to actually make sure that Docker is actually installed in your system, let's actually run the hello world equivalent in Docker. So you can say Docker run hello world. The fact that this is running means that Docker actually has been installed successfully on your system, and you should see something like this. You should see hello from Docker. This actually means that you've actually installed Docker successfully and you've actually downloaded an image. If you see this command, it's actually saying pulling from library Docker. So if you remember the slides, I actually mentioned something called Docker registry. That's exactly what's going on over here. So you actually pulled an image called hello world from the Docker registry and you installed it in your system. So let's actually see how to, let's actually look at where the image is. So you would have to say Docker images. So once you say Docker images, you can see that you just downloaded the image just now. So basically, you just created this, you just downloaded this image called hello world. So basically, now what happens is the image has been created and you just ran it. Now let's actually do the same for our own repository. So I hope that you have this file ready. If you are not coding along with me, that's fine. The repository has all the README files ready to go, and you can follow those instructions and deploy it at your own pace. But for now, let's actually understand what this Docker file is doing here. So basically, if you see the first line, all I'm saying is from Python. So what this instruction is telling me, what I'm actually instructing Docker to do is download Python onto your system. That's what we are trying to do. So basically download Python onto your, basically you're instructing Docker saying that start creating your image. The first layer of the image should be the Python dependency. Then move over all the files that are present here onto a directory called app, and then change the working directory to app. So essentially what you're saying is, this is like saying pip, this is like saying install Python and then cd into that directory. That's what these 3 lines are doing. And then if you are a Python developer, you would know that there is a file called requirements.txt, and then in this you actually specify those packages that you actually need to run something like this. So basically, only person who needs to worry about this requirements.txt is the person who's actually developing the Docker, who's actually building the Docker images for your project. So once you specify the requirements.txt file, all you're instructing Docker is you're saying pip install -r requirements.txt. You're instructing Docker to run this command. And then you're saying, I'm going to run a Python application, and this is my file name. So let's actually try to do that. So if you try to run the app on its own, this is what you have to do. So you would have to say, you would have to do Python app.py. And then what you would actually see is the app is actually now running here. So basically the app is running at this host and this port. Now I haven't used Docker yet. So basically I have not used Docker yet. What I've tried to do is I've just tried to run the Python Flask app as it is. So this is what you should see on the screen. Basically, it's welcome to the Docker workshop. So now let's actually let's actually see what happens when you actually build the Docker image and actually run the container out of that. So to actually build the Docker image, all you have to do is you have to say Docker build -t. Now -t means the tag. So you need to name your you need to actually name your Docker the image, as I said, the name of the car. So you need to say Docker build -t, and then let's actually name it HTN test image. So I'm naming it HTN test image. So and then you need to say dot. What that dot indicates is that that's where the Docker file is. I'm already in the directory, so I'm specifying that this is where the Docker file is. Then you just need to run this command. So try to observe these. Okay, forgot. Need to. Okay, seems like I made a small syntax error. I guess I have to. Okay, let me see. Oh wait, there's a spelling error. Okay, so I made a small syntax error. That's fine. So now let's actually see what's going on. So before I actually show you move on to the Docker run, I just wanted to observe this particular part. So as I said, Docker images is nothing but it's just like a cake. So Docker images, building a Docker image is nothing but like a cake. You're just layering one, you're just putting one layer over the other. So that's what's happening here. So you see here, each line of the Docker file is actually being run one by one. So 1 out of 4, 2 out of 4, 3 out of 4, and 4 out of 4. Each line actually has run separately, and I actually built the Docker image for you. That's what exactly happened here when you ran Docker build. Now let's actually type Docker images and see whether our image has been built. So you can see that my image called test image, I just built it right now. Now how do you run this? Let's use the Docker run command to actually run this image. So you said Docker run -d. So -d is meant for detached mode. I'm going to explain it later, but essentially just put -d over there and just say -p. Now what -p is doing is basically Docker is actually running on a different port. The container actually runs on a different port, and you are actually mapping that container's port to your system's port. That's what's going on here. So you need to say, let me type the command and then explain it. So what's going on here is you're saying run the container from this image called test image that I just built, and then map the port the containers port 5000 to my localhost port 5000. This is a very crucial part to understand. Otherwise, if without this port mapping, you will not be able to view your app. So, and this will also be, Eric will also cover this once more. But once you do this, once you actually run this command, you will see that my app actually started running. And then how do I know my app is actually running? I can say Docker PS. So Docker PS, you see the app actually is up 6 seconds ago, and then this is the port mapping. So now you actually go back to your browser and view the same thing. You should see this exact window as it is on the screen. So that's the beauty of Docker. Basically, you don't need to have Python. You don't need to actually have anything to do with Python. You just need to someone to build the Docker file for you, and then just build the image, and that's it. You should be able to run the app on your own, and Docker will take care of all the dependencies and all that stuff. So I hope that is clear for you. So we'll just take a very short break for 3 minutes, and then we'll get back where Eric will actually get to explain about how you actually deploy a Docker container and move on to Google Cloud.
Alrighty. So I hope everyone's back from the break. We'll kind of take it a bit slow now because we do have a bit of time. So basically, first of all, let's thank Annie for his explanation of Docker and a quick little tour of what Docker is. And now we're going to get to the exciting part. We're going to build a multi-language application, and hopefully it'll work. I mean, I know it works, but hopefully it'll work for you guys, and you guys can use this at your next hackathon or even Hack North. So let's talk about Docker Compose, or how do we actually run multiple of these containers at once? Because as Annie showed, we only ran one container at one time, right? We only ran the hello world. But what happens if you actually want to have multiple of these containers or factories, if you remember our first analogy, all at once, right? How do we get, let's say that Java and Racket container to actually communicate between each other? How do we actually start it running? So the way that we actually do this is through another tool that's kind of Docker adjacent that is actually now within Docker called Docker Compose. The basic idea is that you're going to define, again, this kind of blueprint for how we're going to, build these services. So first off, we're going to imagine, you can think of this as a whole kind of bunch of cars that you kind of want to, race with, or you kind of build. So the way that we kind of define this is first we have the car name. We have, whatever the actual service is doing. So in this case, it's serving the front end. It's serving, the web pages and stuff like that. So we're going to call it the front end. And then next comes the image, as Annie explained. That's the blueprint for how we're going to actually, which car model it is, if you can think of that way. So for example, it can be like Subaru, or the thing that actually contains all the cars, and then the models, for example, like Forester, and then the tag or the year, for example. Right now, we're just going to put latest for saying we want to grab the latest model of the front end that's provided by Docker Workshop in order to kind of use this as a card to start things up. Now, there's an important idea known as ports that we're going to kind of explain. So if you guys remember the factory analogy from here, the basic idea is that in order for your factories to kind of, accept HTTP requests, to actually, accept traffic, what you need to do is actually open up your gates towards all of those roads. You have to actually open it up so that people can actually access it. And that's exactly what ports are. Ports are just basically this definition of where you want to kind of open up your service so that other people can communicate with it. And then finally, we're going to have a command, which is basically, just how do you start your car? Is do you put gas in the front seat and then burn it to start the car? Or do you actually, turn the key to start it? Each of this is going to be language specific and is going to look a little different. So if you guys are familiar with JavaScript or Node, that'd be npm start. Or if you guys are familiar with Python, as Annie showed before, is Python app.py. That's exactly what you would do in Python's case. So this would depend on the language and kind of looks a bit different. But the general idea is that whatever kind of string you have, you want to separate it by the spaces and just put it under the command that it'll run. The next is the env file, or environment variables in general. In general, you kind of want to be able to, to tweak how your stuff is running at runtime, right? Instead of doing it hard coding everything into the actual factory. Sometimes, maybe you want your car to run a bit faster, or, you want it to be red or something like that. In that case, you want to kind of, declare these variables beforehand and be able to include them in. And in that case, we can, have environment files that kind of tweak that stuff out. And so why don't we kind of explore our app that we're going to be building today? So since we're, Hack North is based at Waterloo, and there's a whole bunch of geese here, what we're going to do is build an application to count the geese for us. It's just going to be on the web. It's not going to be anything too fancy, but kind of show you guys how we can use multiple languages at once to kind of, help you guys in your next hackathon, so you guys don't have to argue which language you want to work with. So the basic idea behind our application is we're going to have this kind of front-end service that's going to, serve the HTML pages. It's going to serve what we're going to be able to see. It's going to serve, the stuff that's able to get the geese, going to, kind of create new geese. And so that's what's going to happen at our external port. We're going to have this external port that's going to say, hey, I'm open to the entire internet. You can call me from there. And so, for example, google.com is, kind of alias towards this kind of number that's able to we're able to access from all over the world. So what the browser is going to do is it's going to, call the front end. It's going to get the HTML pages. And once it gets to the HTML pages, then it's going to make a couple of API requests. So as I explained before, this is the highway, and then there's a mailman kind of going on it. The mailman has kind of different addresses it needs to go to. In our case, it wants to, do something with geese. And so that's what we're doing /goose. And then it's doing a couple things once it's there. It's able to, get a goose, and then it's able to create a new goose, which is what post means in terms of the jargon. And then it's going to call this kind of goose counter service that's made in Python. And then from the Python service, let's say for some reason, we don't want to deal with strings in Python or something like that. Well, then we can just work in Racket. And if you guys are familiar, Racket is just a very obscure language, but we're going to show you guys how to actually build a container using that. And we're going to be able to, get a nickname. And so why don't we just kind of jump right into it and kind of, show how we're going to get this entire multi-language application up and running. So first off, I'm going to just, I'm just going to go to the solution branch, and you guys can do this as well. And I'm going to, just start running it and see what happens. Why don't we kind of, test that to see what this actually looks like so we can kind of get used to it. So this is our application. We're able to, create new geese. And then once we have a bunch of geese, we're able to find them all. As you guys can tell, I kind of already did a bunch of testing. And because you can tell I just started up, it means there's persistent data as well. So what we can kind of see here is, we're able to get a nickname. We're able to get coordinates and stuff like that. And we're able to kind of, create a geese and find them. So that's pretty cool, very, but also kind of, I just need to show this one place here. So why don't we kind of, if you guys haven't already, I'd suggest you guys to clone the repo and kind of start looking at it. So why don't we kind of explain how this file is, or how this repo is kind of structured. So first off, as you can see, this is the blueprint that we had before, right? This is kind of defining all the services that we want to use. Then, wait, hold on. I just need to switch back to the starter branch so you guys can actually, do it with me. So as you can see here, there's a lot of stuff we need to fill in and kind of declare the stuff. After that, we can tell that the source file has all the actual different applications and different microservices that we're going to be using. For example, we can see that we declared the front end service here. So this front end service is somehow going to kind of, give out these, sorry, it's just taking a bit long to load, but it's just going to, kind of be able to give us what we see. It's going to give us this page right here. And then what we can see is that we have the goose counter service. This goose counter service here is, sorry guys, seems like my computer's buffering just a little bit, but the goose counter service is going to be written in Python. And isn't that cool that we already have 2 different languages all in one repository that kind of works together to create this thing. But there's another thing, which is we're able to also generate nicknames in a 3rd different language, and one that I'm not sure if any of you guys have used before, which is a bit obscure language known as Racket, and we can kind of look at that too. Now, some of you guys might be saying, hey, maybe he just kind of put the code there, but it's all in Python and stuff like that. Well, why don't we kind of look at this kind of service here? Oh, not the service, but these logs here. We can tell that there are indeed, 4 different services. There's something called Redis, front end, goose counter, nickname. Long story short, we are using different languages to actually create this one bigger application, right? So how do we kind of, go about coding this? Well, the first thing we need to do is, I guess, kind of, figure out how we're going to build the car. So it doesn't matter, we can worry about the parts later. What we're going to worry about right now is how exactly are we going to build the necessary parts to kind of build this car, right? So the first thing, or the general rule of thumb that I kind of follow, that I'm not honestly sure is a best practice, because there are a lot of best practices and so on. But the way I kind of like to follow is I always start by kind of figuring out what my base image is, and that's necessary for any Docker file. That's not necessarily best practice. So because our front end's built in Node or in JavaScript, we have to, get that image. Then the question becomes, what are we going to do in terms of getting the necessary dependencies that we want? How are we going to get those external libraries in? Well, why don't we kind of just follow the steps of what that is for JavaScript? So you guys might not be familiar with JavaScript, but the basic idea is that there are these files known as the package.json, and this just declares all the external libraries that you need. So we're going to just copy it over. And then the way we do this in Node is that we just kind of install all the external dependencies. So that's kind of the steps you guys want to follow. You start from a base image, then you install the dependencies, and then finally, we want to copy the entire project over. So that way, it goes in here, kind of installs all the necessary dependencies. For example, it needs this thing called express, it needs this thing called path, and then it's going to take all of that, and then it's going to, install all of them, and then copy it over. And now we have our car. It's not running yet, but it's going to be a working car. Next, we're going to have to, figure out how does the Python work. So again, we're going to follow the exact same 3 steps again. We're going to start from base image. I use Python 3.8, something called Slimbuster because it's a bit later. And then we're going to install the different dependencies. So how do we do this in Python? You guys will have to figure this out in the specific language you guys want to work with. But the way that we do this in Python is we're going to, copy over this file called requirements.txt that has all of the necessary, all the necessary stuff. And then we're going to do the exact same thing again that we did with Node, right? Except for now we're just going to pip install instead of npm install. So each language kind of has a very similar thing as this. And then we're going to copy over from the source to the destination. Now, what you guys might be wondering is like, how do we do this in Racket? Well, Racket also has a kind of very similar thing, except for there is one important thing, which is Racket doesn't actually have this kind of base image that we can pull from because Racket is, obscure. Because Racket's obscure and doesn't have this kind of base image we can pull from, we have to create our own. And in that sense, why don't we kind of see how we're going to do that? So we start from this kind of base image because there's always this kind of very, very base image, which is just the operating system itself. You can think of it as just a plain old computer that doesn't have anything installed on it yet. Now, the next way that we kind of need to set up Racket is we actually need to download Racket itself. So before we download Racket's dependencies, we have to download Racket itself. And the way that we can kind of do this is we can run, for it to update, we can run for it to add Racket and stuff like that. This will depend on what base image you're using, but the general idea is kind of, you just download Racket the way you would do on any kind of computer. Next, we needed to, download the dependencies. And this is the way that Racket downloads their dependencies. And then finally, we copy over the files. So as you guys can kind of tell, no matter which kind of language you're working with or what kind of service you're working with, the best kind of way to, at least I write it, I'm not sure if this is actually best practices, by the way that works, at least, is to always kind of, start from your base image, download your dependencies, and then copy over the files. And so that kind of works, right? Now the question is, how do we build this? As Annie showed us before, building is actually not that bad. So I'm going to kind of leave this as an exercise for you guys to do. But the basic idea that I can show you here, by the way, if you guys aren't familiar with Makefile, that's okay. The basic idea is that when you type in make, let's say we do like make front end build into the command line, all it does is that it takes whatever comes after like the name here, and it just runs this into the command line, if that makes sense. So just a way to kind of alias stuff so we don't have to type this thing over and over again. So the basic idea behind what we're going to do here with the build file or the make file, or how we're going to build it, is we're just going to build it and tag it with a specific version, as we explained before. And here's the thing that happens with different languages that you kind of need to watch out for. We need to specify the specific file we want to take from. Because, we created 3 different Docker files. How would Docker know which one to look at? The thing you can do is you can tell Docker exactly which file you want to look at. And that's exactly what we see here, right? if we go under source and we look under the front end, we can see that's exactly where the Docker file front end is. And so we kind of want to do a very similar thing in terms of the goose counter and the front end build, right? We want to be able to, Docker build, want to be able to tag it with the specific one. By the way, this is my repo name that I'm going to be using because that's the name I have on Docker Hub. And we kind of want to tag it something, useful. So we're going to do the same thing that we did before. And we're going to specify the file. And that's kind of like the main idea. I'm just going to kind of copy this over instead of typing it all out so you guys can, take some time to digest that and so that I don't have to type the entire thing out. So yeah, I hope that kind of makes sense in terms of how we're going to build stuff and how we're going to start with working with Docker. And then next, we're going to do the same thing for the exact same thing for the nickname generator. Everything's kind of done the exact same way. And so you guys can also, figure out your own optimizations on how to kind of do this to make it a lot easier. But we won't kind of go into that. And next, how we're going to kind of, run all of this up. Because I guess now that we know how to build them, so for example, we can, make build to kind of, build all of them again. How do we exactly run them? How do we actually start this all up? Well, again, it's another command line thing. And it's actually very simple compared to everything else, which is just Docker Compose up. And the reason why this is so simple is because we're declaring how Docker Compose works in another file known as Docker Compose. So this tells you, as we said before, exactly how the services are going to be run and, with all the little details and stuff like that. So why don't we kind of, jump right into this as I explained this before. So the way that we're going to kind of, see how this is going to work is why don't we look at the front end again? Remember how you had to have your car or the image that we're going to start with, right? So this, what did we call the goose counter? Well, we called the goose counter and we built it here and we tagged it with this exact same thing. So that's exactly what you want to do. You want to copy whatever you actually tagged it with and put that in as your image. And then we want to export which ports. So I'm just going to tell you this right away. You can kind of decide which ports you're going to be using, but we're just going to be using 8080 because I'm actually not too sure if I'm going to be honest. And then finally, we're going to add some environment variables that actually this environment variable part isn't necessary. So we're just going to leave that be. And then we're going to actually start it up. So the way that we're going to start up this Python service, because that's what the goose counter's in, is by using, the classic command line stuff. So if we were to type Python space main.py into the command line, it would actually start this service up. So that's the kind of general gist of how we're going to, build the services. It's just kind of following this exact same path. Next, we're going to talk about the nickname generator. So the nickname generator is going to follow the exact same way, right? So I want you guys to think for a minute. What are we going to call the image? Well, it's whatever we tagged it with, right? And where did we specify where we're going to tag it? In the make file. So we're going to go to the make file here. We're going to, figure out what we tagged it or what we called it. What's, the latest model. And the latest model, we called it this. So we're going to copy that over, and then we're just going to have it there. Then we're going to, start the ports up. We're going to, open up 8081, and then we're going to start the command up. And the way that we do this in Racket, if you guys aren't familiar, and I doubt you guys would be, is just called Racket main.racket. And so that's exactly how these different services kind of work together. Now, I won't be explaining this last little part here because it is a bit complicated, but the general idea is that when you want to have, we want persistent data. And the way we're going to do that is through a database, and a very simple database to use is known as Redis. So that's all we're doing here. We're just defining a service called Redis. And what we're also adding is we're adding, where do we want to store the data? And that's known as volumes. So you guys can read up this on your own time, but if you want to kind of have persistent data in Docker, the way that we do this is we do it through volumes. It's still actually stored on your local device. It's just somewhere that you can't see. Or you can, yeah. Anyways, so that's the way that we kind of, explain, or that's the way that we kind of, start up Docker Compose. So I did leave out a little something so that we can kind of discover on how do we actually communicate between each of these services a bit later. So why don't we just kind of, try running the code and see what happens. So first off, we're going to make build, right? Kind of build all the containers. And then we're going to make run. And I know we haven't looked at the source code yet, so we're probably going to encounter some errors, which exactly we do. So as you can tell here, HackNorth goose counter exited because there's an error, because there's some stuff we need to look at. And then we can tell as well that the front end or the other stuff is working properly though. So why don't we kind of test out this app right now and see what's going on. So if we type new goose, we see nothing's happening, and find goose also doesn't work. Why is that? So why don't we kind of like look at the network and kind of try to figure out what's going on. Sorry, I think there's, yep. So we can tell here that there's some like kind of errors, or not there errors, but here pressing these actually doesn't, send any requests. So by the way, for those of you who aren't familiar, when you can inspect Element on your browser, and you can see all the requests over the highway that we're doing. And we can tell here that when we press these, nothing's actually happening. So there's something that's actually going wrong, right? And that's the exact same thing that we see with the goose counter. So why don't we kind of explore what's going on and why it's not working? So why don't we kind of look at the goose counter and see where it's wrong? So now that we kind of, started up all these services, the question becomes, how do we talk between each of these services, right? How are we able to kind of, communicate between our goose counter? So if we take a look back here, if we look at our goose counter, right? How do we actually talk between this goose counter and this nickname? How do we talk between the browser and the goose counter? So first off, we're going to, define how we're going to talk to the nickname generator. So we can see here that we define this kind of function. It's okay if you don't understand Python, it's not a big deal. But the long story short here is that we have this function here that is going to make the request to get that nickname. It's going to say, hey, nickname factory, I want a nickname. And the way we're going to do this is we're going to create like an HTTP connection. And what's important here that I kind of left out for you guys to do is how do we actually call it? How do we make that kind of request? The way that we do this is that this kind of explains the address, but we also need like the specific address, not just which floor you're on, which is what this would be, but like which street you're on, which country you're in. So that's exactly what we need to do here. And the way that we kind of do this, and Docker is really smart about this, is that because it's an internal network, Docker can point you to the right direction by just having you call the container name. And so that's exactly what we're going to do. So what exactly was the container name that we called it? And the container name, by the way, is going to be this service that you put up here. It's a good idea to have this match this part here, but it's not necessary. For example, if I change this to SpongeBob and have it run, we would need to add in SpongeBob here as the stuff. But because we called it nickname generator, we're going to put in nickname generator here. And next, we need to put in the port number, because it's not just enough to kind of tell you which house to go to, but which entrances to use. For example, you can't just go to your friend's house and then if he doesn't tell you which one to go in, you just like break through the window. That's not really a good idea. So you want to kind of be able to go to an actual spot that actually works. And the way that we kind of define this to be open is we defined it to be 881. So that's exactly what we're going to put here, or 8081. And so that's exactly how we're going to create these connections and stuff like that. And I think that should be the only one that's missing on here. So now the question becomes, that's great. That's going to work now, right? So why don't we kind of make build and then make run to kind of see it work all over again. And by the way, just to reiterate, the kind of way that we kind of talk between these services is over this HTTP highway. And if we see it, it may tilt it. And then why don't we see what happens when we start running it? And as you guys can kind of tell, there is one drawback to Docker that we're experiencing live, which is the fact that it takes a long time to kind of load and set up and stuff like that. And so that's why it's kind of, kind of need to worry about that. So next, the question becomes, what's going to happen when I press new goose and find geese? Well, there's an error again. Why is that? Well, maybe the problem is with the HTML page itself. So why don't we kind of look at what's actually going on here? So we can see here, you can see here that we're missing the Docker container and the methods that we actually, want to call this. We're actually missing the client side. How does our, different houses make the calls to the factories, right? So why don't we kind of edit that into here so that we can actually, get started, or we can actually, make these calls. So the way that we're going to do this is we're just going to inspect the code a little bit. So it doesn't matter if you know HTML or JavaScript. I can kind of explain it. So the basic idea is that you can see here, if you see the fact that it's called new goose, this here is probably where we want to, create a new goose. So the way that we define this in JavaScript is that we need to, kind of create an HTTP request. And the way that we do that is using this external library known as fetch. So with fetch, we're going to, do the exact same thing. We're going to call the Docker container, except for there's one important thing, which is, do you guys think that on the browser, because this is technically the code on your browser, right? Does it have access to the internal Docker network? Does it know that goose counter here is actually called goose counter? The answer is no. Think of it. If you expose your entire factory and how it works and like the different kind of stuff, probably wouldn't really, work that well. Also, actually, that's not the reason why. The reason why is because it's not, within the Docker network. So Docker knows everyone's name and stuff like that. But your browser doesn't know Docker. And so your browser wouldn't know everyone's name would be goose counter or nickname generator. So the way that we kind of do this is we know their name through the external port. And the external port, that's kind of a very useful thing when you're working, locally, is known as localhost. So that's the kind of just external port that's going to be on your actual computer. And then finally, because we want to create a new goose, we're just going to, create it. And we're going to do the exact same thing here. We're just going to, call localhost. I also realized that we need to actually format it using HTTP. So that's the way you would do it, HTTP. And we also need to include the port, because again, you don't just want to go breaking through random windows. You have to go to the actual right spot. And we're doing the exact same thing here. We're doing localhost, and we're specifying which port is open. So the way that I got 8080 is because I defined it inside the Docker Compose, as well as Python, which port I actually want open. And so that kind of explains, what we're going to do here. And then we're just going to test it one more time to see if this multi-application thing is actually working, or if I'm just lying to you guys and it can't be done. So we're just going to build it. And then we're going to, it is a bit slow. And then we're going to run it and see what happens. Hopefully this works. And if we kind of look on our new one, it doesn't work. And I wonder why. It said fail to access. Oh, there's Corey's policy. I forgot about that. Long story short, there's this thing that you need to kind of get authorized. I think I accidentally deleted it, but I wasn't supposed to. Anyways, it's kind of a bit complicated to explain, but the idea is that you need to, the web's kind of messy, and you kind of need to work on it a bit to kind of search things up. And since we don't have a lot of time, what I'm going to do is just kind of glaze over that. You guys can look over at, I'm just going to actually show you guys the final code so you guys can understand how it actually would work. And so that way you guys can, kind of understand how we're going to actually get started. So the way that we would do this usually is we would, wait, is it not here? Oh, did I forget something else? Anyways, it's something on the actual, on the actual solution page yourself. I didn't spend enough time clearly to kind of getting used to this, but that's all right. So what we're going to do now is we're going to kind of try to deploy this onto the cloud because that's kind of, more important, I think, in my opinion. So now that we kind of have this entire working application, supposedly, you guys can take a look at the solution and see where I went differently. The way that we're going to kind of do this now, how are we going to, expose this to the entire internet? How are we going to, make sure that, I just can't see it, but your mom and dad can see it? How are we going to be able to do that? So the way that this kind of works is the fact that these factories actually have to be run on computers, right? And the way that people used to do these are still doing it, but it's not as popular now, is to kind of do this thing called self-hosting. So the basic idea is that, let's say there's HackNorth, uwaterloo.ca, and devpost.com. Each of these need to run on local computers, and then we go to this like third party and say, hey, I want you to point whatever address you have to these computers here so they can be the factories, And it's like, that's great because it's able to kind of, maintain your own stuff. You're able to kind of do stuff. And it used to work well when, the internet used to be really small. All you needed was like a few computers. But the problem is, what happens when you're the size of Google? Or like what happens if you want to, be really big? You have to buy more computers. You have to make sure that they can communicate between each other. You have to just handle a lot of that, right? And so then the problem is that you need to hire more people. You have to do all of that stuff. And it takes a long time too to set it all up. So what can we do instead? Instead of doing, this cloud computing, not cloud computing, instead of local hosting, what can we do instead? What we can do is, go to these big providers, Microsoft, Google, Amazon, and we can tell them, hey, I want you to, put all of this out for me instead. I want you to take the instructions I have for my factory. I want you to take my code, upload it to the web, and then run my factory for me so that I don't have to deal with all the infrastructure myself. And that's kind of exactly what, what cloud computing is. All it is just a third party having computers and running your code. So we're just going to take a quick little peek at how exactly we would do this. And I need to kind of figure out where I left it off. Sorry about this. Oh, here it is. Wait, that's not necessarily it. My bad. How's everyone's day been going? Oh, it's here. So the way we're going to do this is we're going to do this on Google Cloud Platform. So I'm not going to explain all the steps. You guys can read the steps in the README on the GitHub page. But the basic idea is that we want to be able to, start up one of these computers on the cloud. We want to be able to, have it running and stuff like that. So the way that we kind of do this is by creating this instant here. So you guys can, create an instant here and then be able to fill all of this out according to the instructions. And there's like a lot of documentation as well. What you also want to kind of note is that we want to, we want to open these kind of gateways for people to kind of have. So once you create your instance, what we're going to do is we're going to do something known, we're just going to connect to computer, which is what SSH means. So once we connect to the computer, we can kind of see just being a bit slow. I already have another session open, so I'll just show you guys that session here. So as we can see, once we can connect to the computer, we have all the kind of necessary stuff. For example, you have Git, and you can kind of Git clone a bunch of stuff, which is exactly what you see here. I Git cloned our current app that we have working, right? So we're going to actually change into that app, and then we're able to kind of run things out. So I'm going to kind of do an example of how this is actually going to be run on the cloud. So we're going to start up Docker Compose. By the way, because Docker Compose isn't actually running on these kind of virtual machines, you have to kind of do this kind of workaround that kind of runs it through Docker. But the long story short is that we're able to kind of, start it up on the cloud, and we should hopefully be able to see this on the cloud, which is exactly what we see here. So if we see here, this is that external IP address. This is, if you guys go to this right now, you guys should be able to see this and, create new geese and stuff like that. You're able to, actually connect to this from the outside world. And as we can see, this is exactly what's happening. We have this external IP address. that's able to kind of, be accessed from all over the world. So that kind of explains how, cloud computing kind of works as a whole, and how exactly would you get this up and running on the cloud. So there's some other ways you can do this, of course. You can go on AWS as well as, other platforms as well. And you don't necessarily have to use a VM, but it is kind of the easiest way to kind of get started because it's just like a computer on the cloud. And that's pretty much it. Yeah, that's our presentation today. I hope that kind of made sense, and I hope you guys learned a lot. I know it's very confusing and a lot of information to jam pack into 90 minutes. But yeah, I will have a, how do you call it? I do have a couple things to note first, though, which is that if you guys are going to use this in your hackathon, you probably should get used to Docker beforehand, because there's a lot of kind of tiny things that you might not realize that's kind of a bit bad to work with in Docker, and that this will take time to kind of learn. So yeah, Andy, do you have any things you want to say?
No, I think, sorry, my mic is, yeah. Okay, so yeah, I think that was a great workshop. I hope you all enjoyed it a lot. Just make sure that think of this code as a template that you can just replace your code with. And Docker is a very great tool, and it'll help you a lot, not just in your hackathon, but when you're applying for jobs as well. So I hope you all got to learn something today. I think that's it. And,
yeah, thank you guys for coming out again.
thank you
I know
guys
it's
for,
not easy on a Wednesday night to spend 90 minutes on at a computer, but yeah, I hope you guys, if you guys have any questions, you guys can hit us up on the emails and stuff like that we left in the hack pack. And yeah, thank you guys all for coming.
Thank you.